First of all, tell me about root bridge election. Let's suppose MAC address 0A, MAC address 0B, 0C, 0D and 0E. Which switch will become root bridge and how?
Switch 1.
D switch 1.
The yeah.
How root bridge election happen?
So small priority.
With the
Then
help of
small MAC
BPDU.
address. Yeah, with the help of video. Yeah.
First all the switches
Safe.
will think I am the root bridge. Correct? All
Yeah.
will
Yes.
generate BPDU, configuration BPDU. But when these all switch will receive BPDU of D switch 1, these all switch will get to know that I am not root bridge, right?
Yeah.
Because their BPDU is superior, their bridge ID is superior. Bridge ID of D switch 1 is superior, best in my domain. So this switch will become root bridge. And if this switch is also acting as a root bridge, two switches are root bridge, then what can be the reason? If both the switches are saying I am the root bridge, then what can be the reason of it? Or let's make it more simple. Switch 1, switch 2, right? For VLAN 10, let's say both the switches are root bridge. What can be the reason?
The VLAN 10 is not configured on the trunk port. The
On the trunk port,
the
VLAN
VLAN
10 is not allowed.
yeah.
Yeah, someone has removed VLAN 10 from the trunk link, right? Another reason can be native VLAN mismatch, right? Let's suppose native VLAN over here is 10 and here is 20. So switch 1 is going to send BPDU of VLAN 10 from the trunk link without tagging, and switch 2 will receive BPDU without tag. It will understand that this BPDU is for native VLAN, for VLAN 20. Again, in that case, BPDU will not get exchanged properly. So both the switches are going to become root bridge, right? Sometime because of this cable faulty also you will find multiple switches are root bridge. Sometime because of misconfiguration of STP also it will show you both the switches will be acting as a root bridge switch. If switches are able to exchange the BPDU, then there will be only one root bridge. STP elect only one root bridge, and here in my case this switch will become root bridge. And you know how root bridge election happens. Then what will be the second election? For RP. Which port will become RP on D switch 2?
Zero or one of them. Zero. Zero.
0/0.
Yeah.
If these two links are there between D switch 1 D switch 2, then definitely this port will become
RP.
RP. On this switch, this port will become RP. On this switch, this port will become RP. On this switch, this port will become RP. So this is your loop free topology. This is what? My loop free topology. How can I verify it? Let me access D switch 1 first and show a spanning tree, let's say for VLAN 1, the default VLAN. You can see this switch is root bridge or not. This switch is not root bridge, but I want this switch should be my root bridge. I want D switch 1 should be my root bridge. What to do? Change the priority profile, correct?
Yeah.
A spanning tree for VLAN 1 and priority C. You can configure priority in increment of this number VLAN 4096. So priority can be 0 or 4096. Then 4096 plus 4096 you can multiply by 2, 3, 4 like this. You can set priority. Let me set priority 0 here. And now show a spanning tree for VLAN 1. Now you can see this switch is the root bridge switch, correct? Here you
Yep.
can see priority became 1. I have configured priority 0 and VLAN ID 1, and this is the base MAC address of my switch. So right now I have total 5 switches in my LAN, and D switch 1 is the root bridge. Rest all the switches are non-root bridge. Here you can see the port role of root bridge switch is DP. All the ports are DP port. On D switch 2 also you can verify it. Enable show spanning tree. You can see G0/1. First G0/0. 0/0 is DP, not RP. 0/0 is DP. 0/2 is the alternate port. This port. What happened here? Root bridge. Bridge ID information. This port should be RP 0/0, right?
Yeah.
0/0
Yep.
should not be DP. So a spanning tree for VLAN 1. 1/1 is RP. Why, guys? See the priority of 1/1 and 0/0. Port priority, cost. So D switch 2 is going to reach root bridge from which port? From 1/1. And if I want to send traffic from G0/0, I can manipulate the cost, right?
Yeah.
I can manipulate the cost. Let me take you to distribution switch and let me see G0/0 is having what port priority? 128.1, and G1/0 has what priority? 128.5.
5.
So based on this,
I-
G0/0 should be RP on distribution switch 2. Am I right?
Yeah.
yes. Supposed to be RPM.
But 1/1 is the RP. Think about it. Why? Why so?
Maybe can I see the bar chart?
Hmm?
Maybe
Same
the
STP is
video
running on
has
both
not
the switch.
estimates.
Same STP is running on both switch.
Maybe it's
Failure
not
of the
the
cable.
cost.
Hmm?
The cost.
Cost is same. You can see on both port. 4
Same.
4. Cost is same.
Okay.
Right? First it is going to check breeze ID. Breeze ID is same on both the port. Then it is going to check cost. Cost is same.
The
Then
cost.
it is going to check what? Sender breeze ID. Sender breeze ID will be also same. Then it is going to check sender port ID. So, and 0/0 has lower port ID.
Transmission quality.
Hmm?
Could it be the reason? If the one cable, G0/0, if the cable is not, you have said just before, if there
No,
is a failure of the cable.
no, port is showing up. Switch 1 is sending BPDU from both the port. On which port switch 2 will receive superior BPDU? 0/0, right?
0, 0. Yeah.
Just last zero. Yeah.
But RP is 1/1. Let me do one thing. Here If you are saying cable is faulty, then I am going to down G1/1 for a moment, shut down, and now do so spanning tree. 0/0 is still DP.
Root becomes the other one. G02.
G02 is now root port. Yesterday I told you na, there is issue on G0 port, 0/0 port in my lab. So better to delete this port, this link. Now everything will work fine. Here you can see on D switch 2 show a spanning tree, and let me up this port 1/1 interface G1/1 no shutdown, show a spanning tree. Now which port will become RP? 1/1. 1/1 is your RP port and status is forwarding. So let's suppose here I have a user IP 10.1. Here is another user with IP 10.2. So if 10.1 is going to send any traffic to 10.2, switch 2 will forward traffic from G1/1. I want to send traffic from this side, from access layer switch. It means I want this port should be RP, not this port, 1/1. How can I change the RP port on D switch 2?
Change
Cost. Increase the cost.
what is a priority port?
Where you will increase the cost? On which port? Here.
Yeah.
So
Yes.
first check distribution switch 2 is selecting RP based on what? Based on cost. Then definitely I will change the cost. Root, it is receiving BPDU on all the port. In all the BPDU, root with ID is same. Cost over here is going to be
Yes.
4 and cost over here is going to be 8.
8.
So based on cost, it is selecting this port as a RP port. If I will set cost value 10 here, if I will set cost value 10 on distribution switch 2, interface G1/1 spanning tree for VLAN 1 and cost 10, and now check show a spanning tree. Now which port is RP port?
02.
02.
02. Now based on which attribute it is selecting RP port? Now see here
Cost.
BPDU is coming, here BPDU is coming, here BPDU is coming, here BPDU is 10, sorry, cost is 10, here cost is going to be 8, and here also it is going to be 8. Root with ID is same. So out of these three, BPDU1 BPDU is the superior BPDU. How you will identify that? Which one is
With
superior?
port number.
Not port. Before
Port
port,
number.
sender breeze ID, designated breeze ID. If switch 2 has lower MAC address than switch 1, then this port will become RP. If switch 1 has lower MAC address than switch 2, then this port will become RP, right?
Yes.
Best path selection is happening based on
MAC address.
designated breeze ID, sender breeze ID. I want this port should be my RP port, and election should happen based on cost, right? So configure lower cost value over here and increase the cost on other ports. On G1/1 I have already increased the cost, right now G0/2 is my RP, but what I want, this path, I want this path between D switch 1 and D switch 2. So see what I can do. Config T interface G0/1 spanning tree for VLAN 1 and cost value 1, and now check show a spanning tree. Now you can see 0/1 cost value is 1 here. Here cost value 4 on 0/2. So just refresh it, and still G0/2 is the RP port.
Need more time. Maybe 50 seconds total.
30 seconds.
30 or 50. Yeah.
Here I am using 0/0 interface, right? So that's why. Actually, it is not forwarding BPDU from 0/0. There is issue in 0/0 interface.
Okay.
Otherwise, yes, now this port will become my RP port. So this way you can control the loop free topology, right? And if you have multiple port, between two switches, then you can use what? Port priority. If cost is same, you don't want to change cost, then with the help of port priority also you can manipulate the loop free topology. Let's suppose these two switches, two links are there. Switch 1 is my root bridge, so it is sending BPDU from both the ports. Switch 1, switch 2, 0/1 and 0/2. BPDU is coming here as well as here. Root bridge ID is same, cost is same. Let's say 10, 10. Right? So switch 2 is going to this time select superior BPDU or RP port based on sender bridge ID. Sender bridge ID will be same in both the BPDU, because root bridge is sending this BPDU to switch number 2. So cost is same, root bridge ID is same, degenerate bridge ID is same. Then next is sender port ID. Based on sender port ID, this port will become your RP. And if you want 0/2 should be RP, here you can configure lower priority. Got it?
But MAC address, but they will not have a same MAC address.
Same MAC address means?
Both
mean-
says the same MAC address.
Yeah,
Port
root bridge
address
is
is-
sending BPDU from two interface, right? So bridge ID is going to be same, sender bridge ID is going to be same, cost is going to be same. So RP will be elected based on lower port sender port ID, right? So you can manipulate the port priority if you want to control RP between these two link. Here you can use port priority. One option is cost, another option is port priority. You can use any one, right? We have already discussed this kind of election. Here we can see some path manipulation. Let me open packet tracer as well side by side, and for now I'm going to close this lab and let me open another simple lab which we had created. Let me add one more lab. STP switch. Let's take 3 switch and connect it in loop. Switch 1, 2 and 3.
Don't use two. Two has problem, as you said.
See, let's suppose switch 1 is my root bridge switch by default. Right, and here I have some user. Here I have some user. If these two users want to communicate, they will communicate via root bridge. Yesterday we had seen this, but it is using longest path. What I want, these users should communicate through this link. Again, here you have to configure path manipulation. Yes or no?
Yes.
If you want, see, by default it will create this loop free topology maybe, right? And you want this loop free topology, right? You want to block this link. Maybe by default STP is blocking this link, right? So based on your requirement, you can create loop free topology, and that's why you have priority to manage root bridge, you have cost to manage the path, best path, then port priority, right? So these features of STP can be used to manipulate the path, used to create loop free topology. For an example, in packet tracer is best for STP because you can see the traffic as well. Let's say switch 1, switch 2, and switch 3 connected like this. Automatically it is going to block one link. First see which port is getting blocked here. See which port is blocked. This port 0/1 of switch 3. 0/1 of switch 3 is blocked. And which switch is root bridge? Let me check. Switch 1.
Switch to
So a spanning tree. Is this switch root bridge? No.
no.
Right? One port is RP, one
Switch
port is DP. Switch 2 is my root bridge switch. So a spanning tree. This switch is root bridge, right? So that's why both port of root bridge is
Designated port.
DP, right? It is going to switch 2 is going to send BPDU to switch number 1. Switch number 1 will relay that to switch number 3, as well as switch 2 is sending BPDU to switch 3 directly. So switch number 3 is receiving superior BPDU over here. That's why this port is your RP port. But I want this BPDU should be superior BPDU here, right? Because what I told you, I want to manipulate the path. Here I have some user and here I have some user, right? And these users should communicate through this path. Through this path. So how I can do this? How I can create this loop free topology? Cost? Cost or something else?
Yeah, cost.
How the BPDU received on this interface is superior because of cost only. Here cost is going to be 38. Here cost is
19.
19, right? So if you will increase the cost over here on switch 3 G0/0, then you will see another port will become RP. Interface F0/2 spanning tree for VLAN 1 and cost value, let's say 100. Cost value 100. Now you can see both the ports are in blocking state. It will take some time and we need to learn this timer as well, that whenever change will occur, then how much time STP will take to reconverge the
30
topology.
seconds. One
See,
quick
still both
question.
the ports are in blocking state. So right now if I have some user here on switch number 3 and some user on switch number 1, can they talk? Can they exchange
No.
data? No.
No.
And now you
Now,
can see
yes.
this port is in forwarding state and this port got blocked, right? And here
So you changing cost per VLAN, or you per port you changing the
Per
cost?
port. Per port. Per port.
Okay.
0/2 is now alternate port and 0/1 is RP port. And here you can see a status of RP is forwarding, a status of alternate port is block. A status of alternate port will be always blocking. So this way you can manipulate the loop free topology in spanning tree protocol. Now STP states.
Full, I have a quick question.
Go ahead.
Please, the cost you did you do that on the VLAN? What should be the standard?
What should be the standard?
The cost, yes, the cost manipulation you did. I realize you did a configuration on VLAN 1.
So
Is that
actually
what is?
PVST protocol is running here. For every VLAN we have a dedicated instance, STP instance. That's why I have configured the priority or cost for a particular VLAN. In case of CST, you will not define the VLAN. Your command is going to be a spanning tree cost 100.
Okay.
Okay. Thank you for that clarity.
STP state disable blocking listening learning
Learning.
and then finally
Forward.
forwarding, right? So all the switch port will go through these states. All the switch port, when port is shut down or device is not connected on the port, then your STP state of port is going to be disabled, means shut down. In case of shutdown, when you will up the port, first your port will enter in blocking state, right, to avoid existing loop. If there is any existing loop, that can be avoided by putting ports in blocking state. Whenever any switch will come up or switch port will come up, first port will enter in blocking state. If port role will get, if port role is DP or RP, then only state will move to listening state. Otherwise, state will stuck in blocking state. If the port role is alternate, then status will be blocking.
Block.
It will not move in listening state. Only DP and RP port will move from
Disable.
blocking to listening, right? For very less time, your RP port or DP port will be in blocking state. Quickly, if the port role is RP, quickly it will move from blocking to listening. And in listening state, your port is going to spend 15 seconds. Why?
Waiting for
Listen the BPDU to listen the
Yes,
BPDU.
to listen the BPDU, to transmit the BPDU, right? But data transfer cannot happen in listening state. In listening state, we cannot send data. Even switch
Data.
cannot learn MAC address in the MAC address table. This is only for BPDU exchange. Only for BPDU exchange. Here, switches are going to exchange BPDU. It can transmit the BPDU and receive the BPDU. In blocking state cannot even send the BPDU, but it can receive the BPDU. Blocking a port in blocking state can receive the BPDU. Right now, here you can see GF0/2 is in blocking state. Switch 3 is receiving BPDU on G0/2, but it will not transmit BPDU from the blocking state. And data transfer definitely not possible in blocking state, not even in listening state. After 15 seconds, your port will move to learning state, and in learning state again port is going to spend 15 seconds. Why?
To
learning
learn
MAC address.
who is
Yes, in
MAC
learning our
learning
address.
state,
information.
port can send and receive BPDU. Data transfer is not possible. It can't send or receive data, but it can learn MAC address, MAC address of users. And after 15 seconds, your state will move in forwarding state. Only forwarding state can send the user data,
Data.
right? So these are STP states. Your states will start from disable when port is shut down. When you will up the port, state is going to be blocking for very less time. All the ports will be in blocking state. Then port will enter in listening state. In listening state, it will spend 15 seconds. After that, port will move in learning state. In learning state, again it will spend 15 seconds, and then port will move in forwarding state. If you will down any port and up, like let's say F0/0 here, so a spanning tree config tree interface F0/0 0/1, I think 0/1, and do so a spanning tree shutdown and no shutdown, and after that check a spanning tree output. Port is in, port role is root, and state is
Listening.
listening, listening, listening. After 15 second, learning,
Learning.
right? And now after 15 second, port is going to be forwarding. Then this port can send user data. It can send and receive user data. But in learning state and listening state, data transfer is not possible.
So,
Hmm.
I have one question. When does it comes about aging time?
Mac is in
You
time.
have aging time, isn't it? Yeah. Is it between disable and blocking or what?
No, no, this is for topology change.
Yeah, okay, thank you.
Okay, this is the
And
reason.
and
Yeah,
initially the cost was 100, and then when you bounce the port, it become 19.
initial
It
cost
means
was 90 on fast Ethernet. I had configure cost 100.
yes. So you didn't save it. That's why it went back to 19. That's what happened. Or you just bounced it, so it went to 19 on its own.
No, no, it's 100 only. On switch number 3, it's 100 only. I have not changed any
Okay,
cost
okay,
on
okay.
switch
Sorry,
number 1.
sorry. Okay, got it.
Right. This is the reason why whenever you are connecting any PC to switch, port is coming in forwarding state after 30 seconds. You can see port is not in forwarding state. It is in listening state. It is in listening state. Now what we need to learn in STP is topology change. How STP is going to behave whenever any change will occur. So see, we have 4 types of changes, topology changes, which we need to discuss. Number 1 is topology change in STP. Number 1 is insignificant topology change. Insignificant topology change means whenever user port will goes down or come up, STP will consider that as insignificant topology change. User port means access port, which is not the part of a spanning tree protocol. Here if I will take to PC, here let's suppose IP address is 10.1.1 and here 10.2. Both are in same VLAN and using IP from the same subnet. I want switch 1 should be my root bridge. So let me configure lower priority here first. Enable config tree, spanning tree for VLAN 1 priority 0. This switch will become root bridge. So a spanning tree. This switch is root bridge switch. All ports are DP. Verify the loop free topology first. Go to switch number 2 and check so spanning tree. I can do one more thing here to make it simple. I am going to set unused port interface range G0/3 G1/023 says shutdown, and so is spanning tree. Now you can see, okay, these are the use port. Here I can also remove G0/0 config T interface G0/0 shutdown. These ports are down, and let me configure link trunk interface range G0/1 to 2 switch port trunk encapsulation.1q and switch port mode dynamic desirable. So interface trunk, right? So both the links are trunk link. Now on switch number 2 also I am going to down unused port interface range G0/4 sorry G1/023 and G0/0 shutdown, and so is spanning tree. Now you can see which port is the RP port. 0/1, which is connected with root bridge, is your RP, and these two ports are DP. 0/3, which is connected with user, right, is DP, means STP is running on LAN port as well, where users are connected. And on switch number 3, let's verify the blocking port interface range G0/1 to 0/0 and G1/023 set, and here interface G0/2 switch port trunk encapsulation.1q switch port mode trunk. Now you can keep users in any VLAN, VLAN 10, 25, 100, any VLAN. By default it is in VLAN 1. And which port is in blocking state on switch number 3? So a spanning tree 0/2. This port is in blocking state. So PC1 and 2 are going to communicate via switch number 1. Let me verify the connectivity first. IP 10.1.1/24. Gateway is not required. Both are in same subnet. IP 10.1.2/24. If I am going to ping PC2 from PC1, will ping work? 10.1.2
Mm, yeah, should be.
ping is working. And how you can verify the path? So IP
Trace.
all. Here is the MAC address of PC1. So what you can do on switch number 2, you can check MAC address table. So MAC address table address this one. Switch is learning this MAC address on G0/3 port. Go to switch number 1 and show MAC address table, then address, and let me copy the address once again. See, switch 1 is learning this MAC address on 0/1 port, right? It means this is my path, correct? Similarly, you can check
Yes.
MAC address of PC4 on switch number 3. You will see that it is learning MAC address on this port. Means this is my path, right? And this way now user can communicate as well. Ping 10.1.1.2. Ping is working. Ping is working. See,
Yes.
This port is DP port. This port is the RP port. And here also RP port. This one is RP port, right? These two are DP. This is also DP and this is alternate. This is my topology. Loop free topology is this one. If I am going to ping, see ping is working, correct? If this user will goes down, if I am going to set this port G0/3 port on switch number 2, you know what will happen? Let me capture this link G0/1. I have captured this link, see carefully, this link. This link is captured. Okay, now on switch number 2 I am going to down this put, means whenever user will disconnect their port from the switch or whenever any new user is going to connect their port on switch, STP is going to treat it as a topology change. Go to switch number 2, config T and interface G0/3 G0/3 and shut down. And before shutdown, here is the capturing. Shutdown.
G0/3 is a PC interface.
G0/3 is the LAN port where PC is connected.
Okay.
There should be one TC and BPDU here. 1 minute. Let me no set the port. Do so spanning tree. 0/3 is not there. No set. And do so spanning tree. 0/3 is there. Port is DP port. State is blocking somewhere. You will find the TC and BPDU here. You have to open it. Open the messages, then you will find somewhere TC and BPDU. Here, who is filtered OSPF? Let me do one more thing here. Instead of RPVST, Rapid Spanning Tree Protocol is running, I am going to run PVST, Spanning Tree Mode PVST. In the production, you will use RPVST only. To teach you, just I am changing the mode. Spanning Tree Mode PVST per VLAN spanning tree. And on switch number 3 also config T spanning tree mode PVST. And is CST also there? No, CST is not there. On Cisco devices you will not find common spanning tree protocol. Now go to switch number 2, interface G0/3 and say shutdown once. Here you can see topology change. Are you able to see, guys?
Yeah.
So what will happen whenever any access port will goes down? STP will consider it as insignificant topology change because see STP is running over here, right? This port is not part of STP domain 0/3. That's why we are saying this change is insignificant topology change. Whenever a switch, non-root bridge switch is going to observe change in topology, your non-root bridge switch will generate BPDU, not configuration BPDU, but TCN BPDU. Right? Yesterday we had talked about configuration BPDU only, and today I am talking about TCN BPDU. TCN stands for topology change notification. Topology change notification. So once this port will goes down or come up, switch 2 will think that there is some change in topology. Switch 2 is going to generate one TCN BPDU. Right? What is the purpose of TCN BPDU? To inform about change to the root bridge. Non-root bridge switch is going to inform to root bridge switch that there is some change in topology. Right? Non-root bridge can't do anything with the change. It can only inform to the root bridge. And whenever root bridge is going to receive TCN BPDU, see here in the capturing, before topology change, there are so many BPDU. If I will open any BPDU, and if you will check the BPDU and the flag, let's say flags, you can see acknowledgement bit is what? Off. Acknowledgement bit is off. But once root bridge which is going to receive TCN BPDU, then what will happen? Root bridge will send BPDU with acknowledgement bit on. Means root bridge is telling to switch number 2, non-root bridge switches, that bro, now I got to know about topology change. Right? Means I have received your TCN BPDU. Now I know there is some change in topology. We need to reconverge STP loop free topology. Right? So here is the TCN BPDU. This port goes down. Switch number 2 has generated TCN BPDU for root bridge. Right? It will not send this TCN BPDU to switch number 3, other non-root bridge switch. It is only for root bridge. TCN BPDU is only for root bridge, and non-root bridge switch will send TCN BPDU from RP port. Interviewer can ask you this question, that non-root bridge switch have observed some change in topology. From which port it is going to send TCN BPDU? From the RP port. I had told you that RP port is the best port to reach root bridge. Right? So this port is the best port to reach root bridge. From this port it is going to send TCN BPDU. Once root bridge switch will receive TCN BPDU, it is going to turn on acknowledgement bit in their configuration BPDU, because root bridge switch is sending configuration BPDU after every 2 seconds, right? After every 2 seconds, root bridge switch is sending configuration BPDU. So in that configuration BPDU, it is going to on this bit, acknowledgement bit, and non-root bridge switch will understand that my TCN BPDU is reached to root bridge. Now it will stop sending TCN BPDU. It will stop sending TCN BPDU. And one more thing, in this capturing, if you will check flags, see in RSTP there was 8 flags, right? But in PVST only 2 flags are there: topology change and topology change acknowledgement. Root bridge is also informing to all other non-root bridge switch that bro, there is some change in topology, right? Topology change bit is on and acknowledgement bit is also on. Acknowledgement bit is on for switch number 2, so that switch 2 can get acknowledgement for their TCN BPDU. And this topology change bit on is for rest other non-root bridge switches, to inform all non-root bridge switches that there is some change in topology. And on's non-root bridge switches will receive TCN bit on BPDU, configuration BPDU. All the switches are going to set their MAC aging time to 15 seconds. What is MAC aging time? What is MAC aging time?
It is the age which takes 10 times to the PPD live, I think.
Yes. So what will happen
2
now?
times
Next
10, 20
operation
seconds.
is going to be topology convergence. Again, STP is going to perform election. Then your topology will reconverge. After that, again, this PC can start talking with each other. Whenever any change will occur and the switch which is going to absorb the change, which is going to see the change, will generate TC and BPDU for root bridge. And in the response, root bridge is going to on TCN bit and acknowledgement bit in their BPDU. This is operation which will happen behind the scene whenever any change will occur. Otherwise, in normal configuration BPDU, you can see both the bits are, it should be off, right? Even in the new BPDU, PVST, you can see both the bits are off. It means there is no any change in topology and no acknowledgement. Only two flags are in use in case of PVST, CST, common spanning tree protocol. Till now we have not talked about types of STP, so just keep in mind these two flags, and both are by default off.
Sir, on doubt,
Go ahead.
topology change acknowledgement is sent to the switch which in the interface is down. So topology change is sent to all non-root bits, right?
Correct.
Okay, sir.
Only root bridge switch generate configuration BPDU. We know this, right?
Yes, sir.
So root bridge switch generate configuration BPDU after every 2 seconds, and both the bits are off. But whenever root bridge switch will receive TCN BPDU, then it will on both bit. Again, see, again what I am going to do on switch number 2, I am going to say no shut on this port, no shutdown. Port will come up, line protocol is up. Here also switch should send. Here see, when port come up, again switch 2 has sent it one, switch 2 sent one TCN BPDU,
TCN.
right? And in the response, root B switch is going to on both the bit. And for how long these two bits will be on? Now see, in the second BPDU, acknowledgement bit is off, but topology change bit is still on. So for how long it will be sending topology change bit on BPDU?
And second,
On, on, on,
is it
on,
aging time?
300 seconds. Aging time is 300 seconds.
So what's the difference between that max age 20 and 300?
Difference between 20 second and 300 second.
Uh-huh. Max aging is 20 here, each
It
packet
means
that we
switch
are
is going
seeing.
to store MAC address for 20 second.
Okay, and then what about 300 then?
If MAC aging time is 300 second, then it will store MAC address for 300 second.
Okay, okay.
See, this topology change bit is still on. Here it is off. For how long root B switch will send TC bit on BPDU? Anyone have idea?
N times?
Maybe once it finish the convergence.
Max age time plus forward delay time. Max age time is 20 seconds. What is max age time? Max age time means, see, root B switch is sending BPDU after every 2 seconds, and the age of that BPDU is 20 seconds. Means never switch is going to store that BPDU for
20 seconds.
20 seconds. That is what MAC aging. MAC is max age time. And what is forward delay time?
If you don't get any response, it will wait for 15 seconds and again it will send BPDU.
The time taken by a port to move in learning state from listening state is known as forward delay time.
Okay.
15 seconds. See, again when this port will goes down, shut down, and so a spanning tree. You can see MAC aging time is what now?
Same as forwarding time.
15 seconds.
Mm,
MAC is,
forwarding.
means if switch is going to learn any MAC address now, it will only store for 15. Means in 15 seconds, switch is going to remove all the MAC address from their MAC address table. Yes or no? So keep in mind one thing, that whenever non-root B switches will receive configuration BPDU with TC bit on, it will set their MAC aging time 15 seconds. By default MAC aging time is 300 seconds. Again you can see on switch number 2. Now MAC aging time is what?
300.
300 seconds. But whenever any change will occur, or whenever a switch non-root B switch will receive TC bit on configuration BPDU, first task is changing the MAC aging time. MAC aging time will become 15 seconds,
15.
right? But guys, do you want this? Like whenever user is going to connect their PC to switch or remove their switch, STP is recalculating the topology. Is it good thing?
No.
Right? Because this is not part of a spanning tree protocol. STP should not consider it as change whenever user port is going down or coming up. So I will talk about the solution. Don't worry. This is first change, topology change in STP. Insignificant topology
So STP will run only on the trunk port,
between the
not in
switches.
the access.
No,
Yeah,
no,
only
it can
trunk port.
run on access port as well, but between the
Access port as
switches,
well. Okay.
right? Whenever a user goes down or come up, your switch is going to generate TCN BPDU. It will send TCN BPDU to root bridge, and after receiving TCN BPDU, root bridge is going to turn on TC ACK bit and TC bit. In second configuration BPDU, it will again off TC ACK bit, and it will be sending TC bit on configuration BPDU. And once non-root B switch will receive TC bit on BPDU, it will set their MAC aging time 15 seconds. If you know this, you can understand all types of topology change. Another topology change is direct topology change. Direct topology change. Direct topology change means if RP port of switch goes down and alternate port is available, that type of change is called direct topology change. Like in my case, you can see RP port on switch number 3, RP port on switch number 2. What is the difference? Alternate port is not available on switch number 2, alternate port is available on switch number 3. So if this RP port will goes down, RP port of switch number 2, it will be considered as indirect topology change. It will be considered as indirect topology change. And if RP port goes down and alternate port is available, that will be considered as direct topology change. So if this RP port will goes down, direct topology change. If this RP port will goes down, indirect topology change. And in both case, STP is going to reconverge the topology, and we need to learn that how STP is going to reconverge the topology. So third type of change is indirect topology change. indirect topology change. Insignificant direct and indirect topology change. Whenever user port will goes down or come up, that will be considered as insignificant topology change. Whenever RP port of a switch goes down and alternate port is available, that will be considered as direct topology change. And whenever RP port of a switch goes down and alternate port is not available, that will be considered as indirect topology change.
Can you write here indirect and direct is confusing a little bit,
Yeah, I can
please?
just a minute. Let me write. 1 minute. RP port down and alternate is available. RP port down and alternate port not available. Got it? Understand
Yeah.
one more thing here, that why topology change is required, why we need TC and BPDU. Let's suppose you have switch 1, switch 2 and switch number 3. Switch 3. DP, DP, RP, RP, DP and alternate. Okay, let's suppose port ID is 0/0 or 0/1, 0/2, 0/3. Let's suppose here I have some PC client machine and here I have some client machine. MAC address of this client machine A, B, C and D connected like this. See, my loop free topology is this one, right? So if I will talk about the MAC address table of switch 2, MAC address table of switch 2. So in the MAC address table of switch 2, what information will be there? Let's say this is port number 5, port number 6, port number 5, port number 6. So switch 2 is going to learn a MAC address on which port?
Port 5,
5.
A. B MAC address on which port?
6,
C MAC address on which port?
5.
No.
3.
Oh,
0/1.
0/1. Okay.
D MAC address 0/1 only. MAC address table of switch 3. A MAC address 0/2, B MAC address
Yes. 0 slash 2.
0/2, C MAC address,
5.
D MAC address
6.
6. MAC address table, right? Let's suppose
Yes.
these users are talking 10.1, 10.2. These users are talking, okay, and MAC aging time is 300 seconds by default. You know this. Means switches are going to keep this information in their MAC address table for 300 seconds, right? Let's suppose this link goes
Yeah.
down. This link goes down. But switch 2 will be keep forwarding traffic for C MAC address from which port? From 0 slash
Root
1.
1
port.
only, right? But
Yeah.
is connectivity there from this side?
No.
No. When switch is going to update their MAC address table after 300 seconds,
After 300.
if switch is not going to receive any traffic over here for 300 seconds, then it will flush the entry. Then new packet will come on this interface. After that, it will update the entry. Means for 300 seconds, your client machines will be forwarding traffic to switch, and switch will be forwarding it to wrong path. That's why topology change is required. If there is no topology change, for 300 seconds, user will be
Not able to communicate.
communicate. User can't communicate. Similarly, on switch number 1, MAC address table, right? Switch 1 is going to learn MAC address AB on this port and CD on this port. Right now link
Yeah.
is directly connected, so switch 1 can understand that line protocol of this interface goes down. Immediately it will flush the MAC address, whatever MAC address it has learned on this interface. But if there is another switch here, in that case it will not understand, line protocol is still up. So if there is no topology change, switch 1 will be again forwarding traffic for C MAC address from this port only. So if no topology change is there, then for 300 seconds your network is going to be down. Network is
Down.
down.
And during topology change, it will be 15 seconds, right?
Yes. Whenever non-root bit switch is going to receive TC and TC bit on BPDU, it will set MAC aging time 15 seconds. Because switches should flush the MAC address, right?
Right, right.
Let's suppose here, from here, someone has disconnected this PC and they have connect this PC over here. Let's suppose this is your path. Okay. Now this port is the RP port and this port is the alternate port, right? So it is going to learn A and B MAC address on 0/3 port now, correct?
Yes.
Yes.
0/3, 0/3. Let's suppose someone has disconnected PC1 from this port, from switch number 2, and they have connected on switch number 1. And this PC 10.2 is sending traffic to 10.1, 10.1, 10.2. Again source MAC C, destination MAC A. It will forward traffic to switch 3. Switch 3 will forward it to switch 2, right? Based
Switch
on
2.
their MAC address table. Because PC is changed. Earlier PC was here, now PC is here. But switch 3 has not updated their MAC address table, correct? It will
Yeah.
update after
Yes.
300 seconds, right? So to avoid these kinds of issues in your LAN network, we have topology change notification in STP. Got it, guys?
Makes sense.
So
Yes.
once you will disconnect this PC from here, it is going to inform root bridge that hey bro, there is some change, and root bridge switch is going to on TC bit. All the devices non-root bridge switches is going to set their MAC aging time 15 seconds. So MAC address table will get update in just 15 seconds. For 15 seconds, definitely there will be issue. Right? There are another solution for that. That's why topology change is required, and we have these 3 topology change. understand in case of indirect topology change how a spanning tree protocol is going to converge the topology. See, switch 3 is receiving superior BPD over here, switch 2 is receiving superior BPD over here, switch 2 is also forwarding BPD from this port, means switch 3 is receiving BPD on this port as well as this port, and superior BPD on 0/1. If this link will goes down, then switch 3 is not receiving any BPD over here, correct? Then the
Yeah.
BPD which is coming over here on this port, that will become superior, am I right?
Yeah.
So this port role will change from alternate to RP. This port will become RP.
But
And how much time it will take to come in forwarding state? 30 seconds. So
30.
after 30 seconds, this port will be in forwarding state, right? And now your loop free topology is this one, changed. So user can talk after 30 seconds whenever direct topology change happen in your network. Got it?
Yeah.
In 30 seconds, STP can reconverge the topology. When this port will goes down, indirect topology change. See, earlier switch was receiving superior BPD over here. Now it is not receiving any superior BPD over here. It is even not receiving superior BPD over here. Correct?
Mm. Yeah.
Mm-hmm.
Now switch 2 will think what? I am the... If
Root
switch is
bridge.
not receiving superior BPD, it mean what?
Root bridge.
You'll try to be root bridge.
Root bridge, right? And it will send BPDU to switch number 3. Switch number 3 is going to receive switch 2 BPDU. Earlier switch 3 was receiving this root bridge BPDU here. Now it is receiving BPDU of switch 2. Root bridge ID is different. So switch 3 will check that, okay, what is root bridge ID? And here I am receiving one BPDU. What is root bridge ID? This root bridge ID is lower, best, right, than this root bridge ID. Switch 3 can understand that someone don't know about this root bridge, the best root bridge, right?
Yeah.
So what will happen here, you know, switch 3 is going to change the port from alternate to DP, and it will start forwarding this BPDU, superior BPDU from this port. But when it can send the BPDU in learning state, right? In listening state also it can send listening, you can say listening state. But for 15 seconds, it can't send. And the previous BPDU which was coming from switch number 2, max time was 20 seconds. That BPDU will expire after 20 seconds here, right? After 20 seconds, the best BPDU will expire over here. Then this port will become DP port, and it will take 30 seconds to come in forwarding state. So total time is going to be 50 seconds to convert the topology. If there is indirect topology change, yes or no?
Yes.
Yes.
In case of direct topology change, STP need 30 seconds. In case of indirect topology change, STP need
300.
50 seconds, 50,
50.
to reconvert the topology. Here, I think right now switch 1 is my root V switch, so a spanning tree, both ports are DP, it is root bridge. Let me take you to switch number 2, enable. So a spanning tree, 0/1 is the RP, great, 0/2 is the DP, very good. Go to switch number 3 and so a spanning tree, 0/1 is the RP port, 0/2 is the alternate port, and this is LAN port. Great. Now let me send traffic from PC1 to PC2 again. Ping. What happened? Why ping is not working? I think on switch number 2 port is down, right?
EC1 was blocked, I think, in the interface.
Interface G0/3.
Port was shut.
No shut. So now let me ping. After 30-second ping will start working. In case of insignificant topology change, STP need 30 second. In case of direct topology change, STP need 30 second. In case of indirect topology change, STP need 50 second. Remember this. And remember the TC and BPDU as well. Now see ping is
Sir,
working.
why is the hyphen T?
For continuous ICMP traffic,
Okay.
it will be keep pinging. Otherwise, it will send 5 ICMP packet. Now ping is working. Let me take you to switch number 3 and I am going to down RP port. Config T interface G0/1 say shutdown. Port down. So is spanning tree. Now you can see here 0/2 port became what? RP port and it is in listening state. So this port will take how much time? 30 seconds to come in forwarding state. Once it will come in forwarding state and here MAC aging time also you can see 15 seconds. Right? After 30 seconds it is going to learn MAC address of PC1 on this port 0/2 port. Earlier it has learned MAC address of PC1 on 0/1 port and now you can see again ping started working. Here you can see and so MAC address table. In the MAC address table you can see PC1 MAC address. Again when this port will come up G0/1 what will happen? No shut. Again switch 3 will receive superior BPDU on G0/1 interface. This port will become RP and it will come in forwarding state after 30 seconds. See again for 30 seconds PC are not able to communicate. Got it? So MAC address table. Now you can see MAC address table is this was the most important thing. If MAC address table will not get updated, then switches will be forwarding traffic to wrong port for 300 seconds. Now you can see again communication started working, right? And if RP port of switch 2 will goes down, then you will see more packet is getting dropped. Interface G0/1 shutdown and so a spanning tree. What it's saying, I am the root bridge. What it's saying, I am the root bridge. And soon after 20 seconds it is going to receive BPDU from switch number 3. And now you can see 0/2 is RP port. So MAC address table. See ping started working, but you can see lots of ICMP packet got dropped here. If you will count, around 25 packets are there. 50 second. Praful, what is the solution? Solution is there, but nowadays we are not using PVST protocol. We are using RPVST. In RPVST, for all types of changes, your spanning tree protocol can reconverge the topology quickly. How? We learn that. Just 1 minute. Hello? Yes. Yeah. So for insignificant topology change, we have solution called port fast. Port fast. If you will enable port fast on access port, then your port will come in forwarding state quickly. See here, again ping is working, and I am going to up port on switch number 2 also, so that my topology is on default. Interface G0/1, no shutdown. Okay, and now let me ping. Ping is working. Some packet will
Yeah.
get dropped because there is again change, and same thing is happening behind the scene. TCN BPDU, and in response root bridge will turn on. TC bit and TC ACK bit. See, ping is working. Now let me take you to switch number 2, and I am going to down interface, LAN interface G0/3, config T, interface G0/3, shutdown, and then no shutdown. See, port is no shut, line protocol is up, but still communication is not happening. So a spanning tree, because port is in listening state 0/3, right? It will come in learning, then in forwarding. To avoid this, what you can do, you can enable
Port fast.
port fast here. If port fast is enabled, to avoid 30-second on access port, you can enable port fast. When port fast is enabled, then your access port will come in forwarding state quickly. Let me enable it. A spanning tree, port fast, enable. Port fast, you can use H keyword for all access port. For all access port, if you have configured this port as an access port, switch port mode access command is running, then use edge command here. Or you can enable it on interface basis as well. Interface is 0/3, and a spanning tree for VLAN 1. A spanning tree not for VLAN 1, port fast, like this. Port fast, and now if this port will goes down, shut down. See, ping is not working. One port will come up. Quickly port will be in forwarding state, no shutdown. And do so spanning tree. You can see port is in which state? Forwarding state. Now it will skip listening and learning state. And here also it's saying this is edge port. Right? All the edge ports should have port fast features. Right? You will enable port fast feature on all the access port to avoid 30-second. What is the solution for direct topology change? We have a solution feature called uplink fast. Uplink fast. See, you know what uplink fast will do? Uplink fast will force the switch port to come in forwarding state quickly. In direct topology change, it was taking 30-second. Why? Why it was taking 30-second? When this port will goes down, this is alternate port, right? Now switch is receiving superior VPD over here. This port will become RP port, and it was taking 30 seconds to come in forwarding state. So uplink fast will avoid that 30 seconds. It will escape listening
Yes.
and learning state. Ping is working. Ping is working, and on switch number 3, if I am going to down RP port, nowadays we are not using these features, right, to improve the STP, because we have RSTP. When we were using PVST protocol, at that time we were using these features, right, to make our STP faster. Interface G0/1 set and do so spanning tree. Now you can see 0/2 port is root port, right, and it is in listening state. After 15 seconds it will come in learning state. Say no set again. Let me enable uplink fast service. Command is very simple: spanning tree uplink fast. Uplink fast is enabled, and now I am going to down G0/1 interface G0/1. Say shutdown and do so spanning tree. Now you can see RP port is in forwarding state quickly, right? Again shutdown and no shutdown. See how many ICMP packet is dropped, not drop. All are working well, right? Here again I am going to down this port, shut down. Do so spanning tree. See quickly this port is coming in forwarding state, right? And there is no any packet drop. So this is your solution for direct topology change. Can anyone tell me the solution for indirect topology change? For indirect topology change, you can't avoid all 50 seconds. You can reduce the time. You can reduce from 50 to 20 seconds. How? With the help of a feature called backbone fast. With the help of a feature called backbone fast, where you will enable backbone fast on switch number 2, where RP port and alternate port is not there. RP port is there, alternate port is not there. Here on switch number 2, right? So just keep in mind what is uplink fast, what is backbone fast, what is port fast. Port fast is required in our PVST as well. Port fast is required there as well, right? But these feature uplink fast, backbone fast, these are not required, right? STP is designed in another way. RSTP is designed in another way. Soon we'll discuss that. We will use flags there. Okay, so here your command can be a spanning tree and backbone fast. You can enable this command on this switch, right? So these are my topology change in STP. Now we have multiple types of spanning tree protocol. Whatever we have discussed, whatever topics or concept we have learned in spanning tree protocol is your CST, common spanning tree protocol, but CST is not running on order. See what I am saying. Let's suppose I have two switch. Let's make the simple topology. Switch 1 and switch 2. I have two link here, 0/0 and 0/1, let's say. Switch 1, switch 2, 0/1 and 0/2. Guys, for topology change, you need to practice a lot, right? Here I have some user in VLAN 10 and 20. Some user in VLAN 10, some user in VLAN 20. What STP will do here? STP is going to block 1. STP is going to block one link. This one. Let's suppose these are in VLAN 10. I have 100 users in VLAN 10, 100 users in VLAN 20. So CST was the open standard protocol. Common spanning tree protocol was the open standard protocol which doesn't support load balancing for all the VLAN 10, 20, 100, whatever VLANs are there will be single STP instance. Single database means for all the VLAN, your switch 1 or switch 2, one switch can be root bridge and rest all the switch will be non-root bridge for all the VLANs. But Cisco designed a proprietary protocol for load balancing, right? Because in case of CST, one link is underutilization, one link is overutilization. Let's suppose STP has blocked this port, right? So until and unless this link will not goes down, right, you will not find any traffic over here. This link is overutilization, forwarding all the traffic from this link, and this link is underutilization. There is no any traffic on this link. So to use both the link, we come up with another types of spanning tree protocol called PVST, per VLAN spanning tree. This is Cisco proprietary protocol. For other vendor non-Cisco devices, we have CST. For Cisco devices, we have PVST. PVST means for a particular VLAN, STP is going to create a separate instance. Like if I have two VLAN 10 and 20. 10 and 20 means one STP instance is running for VLAN 10, one is running for VLAN 20. I can configure switch 1 as a root bridge for VLAN 10, switch 2 as a root bridge for VLAN 20. I can use this link in forwarding state for VLAN 10 and this link in forwarding state for VLAN 20. And if any link will goes down, then you know, like the same link will be used for both VLANs, VLAN 10 as well as VLAN 20. So to achieve load balancing, we come up with another protocol called PVST. But PVST was not compatible with CST. Let's suppose this is Cisco device, this is non-Cisco device, right? So non-Cisco devices will have CST protocol, Cisco devices will have PVST because they want load balancing. In that case, it was not working, it was not compatible. So Cisco has replaced PVST with PVST plus. PVST plus. So we have how many protocol types of spanning tree protocol? STP. Tomorrow I will give you better example for PVST. Don't worry. First one is CST, common spanning tree protocol. We have already discussed this. Another protocol is PVST. Third protocol is PVST plus. PVST and PVST plus both are same. Difference is what? PVST is not compatible with CST and PVST plus is compatible with CST. But there is one issue in this all protocol. Convergence. You have seen this, right? In case of direct, indirect, it is taking time. That is convergence issue. So that's why we come up with another protocol called RSTP, which is solving the timer issue. But again, our PVST is similar like CST, but it is fast. You can say fast CST, but not load balancing, right? Load balancing. So Cisco come up with their again on protocol for load balancing. That is called
RPVST.
Yes.
RPVST. PVST, fifth one. But again here is issue. Let's suppose I have 100 VLANs. So for 100 VLANs, STP is going to maintain 100 instances. It need more memory, more CPU, right? So our best protocol is not CST, not PVST, not PVST plus, not RPVST, MST. But if I will talk about the production, so in production we are using, most of the time you will be using RPVST.
There is no RP-based plus.
Hmm?
There is no RP-based plus.
RPVST. Yeah, we will have class on this. Now our next topic is understanding different types of spanning tree protocol only. Right? So we will discuss what is the issue with CST, what is the issue with PVST, why we come up with RSTP, and then RPVST, and after that MST. Right? So tomorrow we'll cover maybe till RPVST, and then in next class MST. So two more classes will be there for spanning tree protocol. After that we will have some scenario. Okay, till then you can revise the topology change. Today we are focused on topology change only in STP.
I have one
So
question
one question.
actually.
Test all types of topology change in your EVNG: insignificant, direct, and indirect. Yes, go ahead, please ask.
Is RPVST is compatible with other vendor switches?
Yes.
Okay, sir.
After
Can
PVST
you
plus whatever protocol Cisco has designed, those are compatible with open standard protocol. Like on non-Cisco devices,
Okay,
you
sir.
will configure RSTP, and on Cisco devices, you will configure RPVST. Got it?
uh,
Yes,
sir,
sir.
I have a question.